Hello, 7th grade. Hopefully you're all doing what you need to do, and hopefully the two of you that had the same answer as somebody else, but after them, have looked at your email. Feel free to tell me what's going on. I am just guessing. I could only look at the history to figure out who did what on the science, and that was the process I took. If I was wrong, you gotta let me know, and we'll talk about it. So find the least common multiple for each set of numbers. So least common multiple is the smallest number they'll both go into. 8 and 12 will go into 24. 12 and 18 will both go into 36. You can do this by listing them out, or you can do it by their product of primes, like we did yesterday. 10 and 12 will both go into 60. I just think through them. Oh, 12 gets to 60. Oh, I know 10 will go into 60. 12 and 24 is 24. 24 times 1 is 24. 12 times 2 is 24. It can be that lowest number, least common multiple. You can do with small numbers like this, but remember, you can also be like, oh, what are the same amount of product of primes that they have? So this one is 2 times 2 times 3 times 3, and this one's 2 times 2 times 3. Most number of 2's, hey, there's 2 2's. Most number of 3's, 4 times 6 is 24. Oh, excuse me. 4. I did something wrong. Well, I will have to look at that. I apologize. I told the 7th grade or 6th grade my brain was fried. It is right now, but I'm trying to get through this so you got stuff to do tomorrow. Learn to add and subtract fractions. Hopefully you remember from long times ago, but we'll go on it. From January 1st to March 14th, any given year, Earth completes approximately 1/5. So if I divide their orbit into 5 parts, one of those 5 around the sun, while Venus completes approximately 1/3 of its orbit around the sun. Okay? So, Venus 1/3, Earth 1/5. All right? The illustration shows what the positions of the planets would be on March 14th if they started at the same place. To find out how much more of its orbit Venus completes than Earth, you need to subtract fractions. Now, subtracting fractions is not a complicated process, but fractions scare some people. So, we would take what is left, and we'll start with this. So, write the answer in simplest form. We're adding fractions. Now they're being very nice right now. We have 5/8 and we have 1/8. When we're adding, denominators stay the same. Add numerators. 6/8, that reduces to 3/4. Because I divide by 2, divide by 2, oh, we get 3/4 as our answer. This answer, that's the answer I want. If you get here, show me what it is, show me how you got it, and we'll go. Here's what they show you. Add the numerators, and simply 6/8. All right, that's 3/4. Okay, now we do the opposite. We do subtraction. Works the same way. Denominators stay the same, 11. 9 minus 4, oh, that is 5. 5 11ths. I don't see any way it can reduce. No common factors. We have our answer. Subtract the numerators, keep the denominators the same. Oh. And we get our work. All right. 5/6. Now, if you think of 5/6 like this, it's a candy bar. And I've got 5 pieces of that candy bar in my pocket. The colored in ones are the pieces I have. All right, 1, 2, 3, 4, 5 pieces. 1, 2, 3, 4, 5. Oh, I need 5 pieces, don't I? 5 of the 6 pieces I have in my hand. This person has they have 1 of 6 pieces. So, I keep the denominators the same because the pieces are the same size pieces. 6. 5 plus 6 is 6. Do you see how if I add this one over here, I will have one full candy bar. Well, 6 over 6 divided by itself is 1. And yes, we do get an answer of 6 over 6, which is simply 1. My picture shows how it comes together. You can kind of go back and take a look at that. But here's the math that shows 6 over 6 is 1. All right. You can think of a candy bar cut into 10 even pieces. I got 7 of those pieces. Somebody takes 4 of those pieces away. How many pieces are left? Well, I still have 10th size pieces, so that denominator stays the same. 7 minus 4 is 3. We do our subtraction. 3/10. All right. To add or subtract fractions with different denominators. We've done all of them with the same denominators. Now we're going to look at ones with different denominators. This is going to involve changing what the fraction looks like. It's still the same size, but we're changing what it looks like. We must find a common denominator. Hey, that's why we needed to do LCM yesterday. Okay? Find the LCM of the denominators. What's that smallest number they'll both go into? Multiply the denominators. There's 2 ways. So we can either find the LCM and get them both to that, or we can multiply the denominators by each other and get to that. All right, let's look at it. The LCM of the 2 denominators is the lowest common denominator. It makes it the easiest. So when we look at this, 6 and 8, what is the smallest number they both go into? They both go into 24. I do know that. 8 will go into 24. 6 will go into 24. Now I got to figure out, what did I multiply by 6 to get 24? 6 times 4. If I did it to the bottom, I need to do it to the top. Do you see how 4 over 4 is just a fancy 1? So we didn't change anything. We just took 4 over 4. Because 6 times 4, that gives us 24. 5 times 4, that gets us 20. So 20 over 24, that is the same as 5/6. We just took it times 4 over 4 to get a common denominator. 8. What do I take it times? 8 times 3. So if I do that, 3 over 3. Oh, that's a fancy 1. 8 times 3 is 24. 7 times 3 is 21. It tells us to add them. 20 plus 21, since we have common denominators we can add, we get 41 over 24. Okay. Hopefully you remember how to turn it back into a mixed number. 41, numerator on top, goes under the house. 24 is the divisor. Times 1, that's 24. We got to the decimal, so 11 minus 4 is 7. 4 minus 3 is 1. So this is the whole number, 1. 17 over 24. 17 over 24. The 17 goes up there. Oh, that's what is over the 24. This number and this number are the same. All right, let's have them show us their work. This lesson will take a lot of practice, so it's good you have a video. You can go back over this. All right, so we got to get common denominators. 4 over 4. Hey, 3 over 3. What I did that. All right, so we get that 20 over 24 plus 21 over 24. They do the addition. They get 41 over 24, and they say, hey, that's 1 and 17/24. I showed you how to use the division to do it. We got the same answer. Good things. All right? So the estimate is, oh, that's about 1, that's about 1, so it should be about 2. That is about 2. That's a reasonable answer. This is a way to think. Am I kind of in the right ballpark? All right, 2/3 minus 3/4. Now, I have to look at 3 and I have to look at 4, the denominators. What's the smallest number they'll both go into? I know 3 and 4 will both go into 12. Yeah, that's what they'll both go into. Well, how do I get 3 to be 12? I take it times 4. 4 over 4 is 1. 3 times 4 is 12. 2 times 4 is 8. I just got a equivalent fraction. Oh, over here. 4 times 3. Well, if I do 3 over 3, that's just a fancy 1. It doesn't change anything. 4 times 3 is 12. 3 times 3 is 9. All right. So then we have our subtraction. All right. 8 minus 9. Well, 8 minus 9, you would think normally we can't do that. But if we think positive 8, negative 9, subtract and keep the sign of the bigger, negative 1 over 12. We have our answer. Oh, we can do that. Let's watch what they do. Since it's already a proper fraction, we can leave it as is. We didn't have to change it. All right? They do the same thing we did. This side times 4 over 4. That side times 3 over 3. 8 minus 9, that is negative 1/12. Notice I wrote it a little different than them. This negative 1/12 or negative 1 over 12. Those are the same things. Same difference. All right. And if we think about it, this is about 1, that's about 1. That makes sense that it's about 0. All right. Well, somebody took the second step for us already. Now, we've got negative 2/7, 1/3. Okay? So, don't worry about the negative so much. What will 7 and 3 both go into? 21. That's what it is. They'll both go into 21. Well, how do I get 3 to be 21? I take it by 7 over 7. So, I have 7 over 3 times 7 is 21. On this side, I'm going to need to take it times 3 over 3, because 7 times 3 is 21. Remember, getting that common denominator. 2 times 3 is 6. And let's not forget, it was 3 times negative 2, so negative 6 is actually the answer. All right, negative 6 plus 7, when we think about our adding or subtracting integers, one's positive, one's negative, subtract. 7 minus 6 is 1. Keep the denominators the same. Keep the sign of the bigger. 7 is bigger if we look at just the numbers. Positive 1 over 21. Have to take time to think about them, but get that common denominator, do your subtraction. You guys can do this, but it's going to take time and thought. Two things we don't like to give up or do, all right? But they did the same thing, times 3, times 7 over 7, fancy ones, all right? Negative 6 over 21, 7 over 21, we get 1 over 21. All right, that's about a half, so it's right around 0. It's about a good estimate answer. All right, write the answer in simplest form, adding them. 5 and 6 are what we're looking at, these bottom two numbers. I know they both go into 30. So how do I get 5 to be 30? I do it by 6. If I do it on the bottom, I do it on the top. Because 6 over 6 is a fancy one. 6 times 5 is 30. 2 times 6 is 12. I bring my addition sign down. How do I get 6 to be 30? Oh, times 5. Times 5. 6 times 5 is 30. 5 times 5 is 25. I do my adding. I get 37 over 30. Now I can do my division again. Numerator in the inside, denominator on the outside. That'll go in there one time. Hey, I'm to the decimal. Okay, 30. Oh, this is the whole number because that'll be how many groups they fit into. This is what's left, 7 of them in the numerator, and 30 of them there. Because if you think of it like this, oh, if I have 30 over 30, that's the 1. Well, if I take 30 away from 37, aren't I just left with 7 to put there? The 30 over 30, that's the 1. Oh, we took 30 away. 7 remains. 7 over 30. 1 7/30. Hopefully you already remember how to do that, but just in case. All right. Today's lesson is a bit longer, so stick with it here. We're going to do it. Hey, they got the common denominators using the same method I did. We got that, and there's 37. That equals 1 7/30. All right. Let's go again. 2/5 minus a half. All right, I know 5 and 2 will both go into 10. 10's my least common denominator. Hopefully you guys can do those least common denominators just as easily as I can. All right, times 5 over 5, because 5 over 5 is just a fancy 1. And anything I multiply by 1 stays the same. 5 over 10. Oh, I could reduce that to 1/2. They're the same problem, or the same fraction, just they look different. And this one, I multiply that by 2 over 2. My. That makes 4/10. Oh, 2 over 2 is a fancy 1. It doesn't take anything out of there. Positive 4, negative 5. Oh. 5 minus 4 is 1. Since the negative number is the actual bigger number, 1/10 negative will be my answer. I really expect to have questions 7th grade. I will try to have Google open, the Google Meet open, the second half of today's lesson from like 10:30 on, 10:35 on, okay? We can work through a bunch. We'll have it show on the computer screen and go from there. So they got common denominators just like I did. 2 over 2 makes 4/10. 5 over 5, that makes 5/10. And we have a very good answer there. Negative 1/10. And we think about that. That's about a half. That's about a half. Hey, negative 1/10 is close to 0. All right, and then here's my problem again. Let's look at this one. We have negative 3/5 and we have negative 1/2. Look at the denominators. 10! 10 is the number I see should be the least common multiple of both of these. All right. I put the addition sign. So how do I get 5 to be 10? Well, I multiply it by 2. So to keep everything the same, 2 over 2, that's a fancy 1. Gives me 10. 3 times 2 gives me negative 6. So, negative 6/10. Okay, that's good. These are both positive, so 5 times 2 makes 10. 5 over 5. That's 5/10. Negative 6 plus 5. 6, they're opposite signs, so 6 minus 5 is 1. The negative is bigger, so it stays with it. Keep the denominators the same. Watch these again. Have it pulled up on your phone. You can look at them as you're going through. There's your answer. Let's go back and look at things. Okay. And negative 1/10. We think about that. That's about half. That's about half. So it's about 0. Now we're back to our problem. 1 Earth year, Jupiter completes about 1/12 of its orbit of the sun, around the sun, while Mars completes about 1/2 of its orbit. How much more of its orbit does Mars complete than Jupiter? This is where we have to create a problem. Of 1/2 minus 12. We got to get a least common denominator, but don't think too hard, man. 24, yeah, they both go into that, but there's something else a little bit smaller. Will 12 go into 12? Yes, it will. Will 2 go into 2? Yes, it will. That's already 12. I can leave it as it is. This one, if I take it times 6 over 6, 6 times 2, that's 12. 1 times 6, that's 6. 6/12, that is 1/2, right? See, taking it by that fancy one doesn't change it. It just changes the way it looks. All right. 6 minus 1, well, that's 5/12. So, how much more of its orbit does Mars complete than Jupiter? Mars completes 5/12 more of its orbit. We're going to get to see a picture, hopefully, to show us this. Here we go. They got the common denominators. They showed 1 over 1 times that. I didn't, because that's just a little extra work. We do it, and we subtract 5/12. 5/12 more of its orbit than Jupiter. All right, it takes Michelle 5/12 of an hour to drive to work. It takes Luke 1/2 of an hour to drive to work. How much longer does it take Luke to drive to work? So we know it takes Luke longer. So in my thought process, I like to put Luke first. Luke takes longer. If we subtract Michelle's time from it, we will get the answer of how much longer. I've got to make this one 12, because that's already 12. 6 over 6. That will, oh, good. 6/12. 6 times 1 is 6. 6 times 2 is 12. Minus 5/12. That's your 1/12. And you have your answer. It takes him 1/12 or her 1/12 of an hour longer than Luke to get to work. Let's go ahead and check it out. Make sure we did it correctly. All right, that looks pretty dandy fine. You guys are ready to roll on your homework. Bye now.